Hello everyone. So today we are going to solve this LeetCode problem, which is binary watch. What this problem says that we have uh, what this problem says that a binary watch has four LEDs on top to represent hours, okay, and six LEDs on bottom to represent minutes. These four LEDs represent hour, and these six LEDs represent minutes. Okay. And each LED represents a 0 or 1. Okay, means 0 means it is off and 1 means it is on. Okay, so for example, this watch is showing 4:51. Okay, we can see here, mm, here we can see R4 is on, so R is 4. Okay, and in minutes, these 4 bits are on, which is 32 plus 16 plus 2 plus 1, which is 51. Okay, so it says 451. Now this is what the problem says. Now what we have to do in this problem, let's see. Given an integer turned on which represents the number of LEDs that are currently on, ignoring the PM, this PM LED we will ignore. Okay, it is to set AM and PM. Okay, this we are not considering. Return all the possible times of the watch you could represent. Okay, so it says that number of LEDs turn on are 1, 2, and so on. How can be 4 we have here, 5, 6, 1, 2, 3, 4, 5, 6, 6 we have here. So 4 plus 6, how many total LEDs we have? We have 10. Okay, so what can be our turned on? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so our 9 LEDs are turned on, 9 and 10. 10 LEDs are turned on, can be, and we have to return the timings, what timings are possible. Okay. Suppose one is LED is turned on, so any of these time could be there. Okay. And if 9 LEDs are turned on, no time is possible because 9 means that suppose only one LED is turned off, rest all are open. Okay, so suppose here what we'll have, 8 plus 4 12, 12 plus 2 which is 14 and 15, but 15 is no, we can't represent because we are representing in AM and PM, so the maximum time could be 0 to 12 only. Okay, so that's why 9 LEDs can't be possible. So what approach we can use over here? The approach that we can use over here is we can find for all these 9 bits. Okay, so these suppose 1, 2, 3, 4. These 4 bits represents our R 1, 2, 3, 4, 5, 6, and these 6 bits represents our minutes. Okay, we have total 10 bits. Okay, so now what we can do, we can simply use this approach to find our total. How I can find is that the uh, we extract these 4 bits upper to get our hour and these to get our minutes, and by iterating through all these 104 bits, that is 10 to the power of 10, it's 104. So we have, by iterating through this, we can find the number of bits, um, number of times that are present for each bit. Okay, now let's say with the help of code how we can achieve this. Okay, So what we have been given an integer turn on which represents number of bits that are turned on. Okay, from 1 to 10. Okay, so now what we'll say, we can take a vector string to store our answer. Okay, now what we'll do, we iterate through all these bits, that is from 0 till 1024 and I. Okay, we'll iterate through all these, and what our R is in first 4 bits. So first 4 bits we can initialize as I by 6, and our last 6 we can I and 60. Okay, this will give us our first 4 bits, and this will give us our last 6 bits. Okay, now what we can do, we can see, we have to check if our R is less than 12, then only we'll consider it. Okay, or if minute is less than 60, then only we'll consider it. Also what we have to check that our number of set bits, we can use this function, number of set bits in our current I, if it is equal to turn on means the number of bits that are turned on. If these three conditions are true, then we'll consider that time and we'll push it into our answer. How we'll push back? We'll convert R to string. Okay, then we'll add our colon, and then we'll add our minutes. And for adding minutes, we have to add a 0 if it is from 1 to 9. Else we can add just 10 to 59. Okay. So if m is less than 10, then we'll append a 0. Else we'll not append anything. And simply at last what we'll do, we'll add to string m, that is minutes. Okay, and finally what we'll do, we'll return our this answer vector of strings that will contain all the possible timings which are possible for the given turn on, which is number of set bits. Okay, it will store this. So it was a simple problem, but you have to think through the bit manipulation technique. If you have any doubts, just put it in the comment section, and keep learning, keep growing.